In this video, we are going to look at trigonometric ratios. So as you can see on the screen, I have two right angle triangles, and that's because trigonometric ratios only applies to right angle triangles. Now, Pythagoras' theorem also applies to right angle triangles, and we know how to use Pythagoras' theorem. If you have two sides of a right angle triangle, and you're missing one side, you can use Pythagoras' theorem to find the missing side. Now, when Pythagoras' theorem doesn't work, we turn to the trigonometric ratios. So, before we could start using the trigonometric ratios, which is your sine, cosine, and tangent, which we say sine, cos, and tan, first we have to know how to label these right angle triangles with respect to the angle that's given or the angle that you want to find. So this theta here will be the angle that's given or the angle that we want to find. So as we know, the side opposite the right angle would be a hypotenuse, or the longest side on the right angle triangle. So if I draw a line from the right angle, it will touch this side here, which will be the hypotenuse. All right, same thing on this triangle. So I'll just write HYP for short, for hypotenuse. And now notice in both triangles, I have theta in two different positions. So the labeling of these triangles will be affected by the position of the angle that's given or the angle that we want to find. Now, of course, it's a right angle triangle and the right angle will be given. So we're talking about the other angle that's given besides the right angle. So if I were to draw a line from this angle theta, it will touch this side. And we call this side the opposite side. Now, in this triangle across here, theta is up here. So if you do the same thing and draw a line from theta, it will touch this side down here. And we call this side the opposite side, and I'll use OPP for short for opposite. And then the remaining side, which will be here, so we have the hypotenuse, we have the opposite, and we have this remaining side. Here we have opposite, we have hypotenuse, and this is the remaining side. We're going to call the remaining side the adjacent side. So here would be the adjacent side. Right, and I'll put ADJ for short, for adjacent. So we can see that these two right angle triangles are labeled differently depending on the position of this angle theta. So now let's look at what the trig ratios are. So we'll have sine theta is equal to the opposite over the hypotenuse. We'll have cosine theta is equal to the adjacent over the hypotenuse. And we'll have tan theta, which is equal to the opposite over the adjacent. Now, as I said, SIN is short for sine, COS is short for cosine, and TAN is short for tangent. Now, before we move on, I just want to highlight something, that you could only have sine, cosine, and tangent of an angle. So sine doesn't exist by itself, cosine or tangent doesn't exist by itself. It must be of an angle. So it must have sine of something, cosine of something. You can't just write sine by itself, or cosine by itself, or tan by itself. Now, just writing these ratios shorthand. So we have sine theta is opposite, so we write OPP over hypotenuse. Cosine theta, we write ADJ for short, for adjacent, over hypotenuse. And tan theta, we put OPP over ADJ, so that's short for opposite over adjacent. Now we have a saying, so ka toi, which is how we remember these trig ratios. So let's write it out. So, ka, and toi. And what this means is sine is opposite over hypotenuse. As you can see here, sine is opposite over hypotenuse. Cosine is adjacent over hypotenuse, so that's ka. Cosine adjacent over hypotenuse. And T for tan is opposite over adjacent. So you see tan here, tan theta is opposite over adjacent. So anytime you want to remember what your trig ratios are, you just say so, ka, toi. Now, you're probably wondering, what are we going to use these trig ratios for? So for a right angle triangle, you could have missing angles, well, besides the 90 degrees, or you could have missing sides. And the trig ratios will help us find the missing angle or the missing side. Now, if you look at your trig ratio, all three of them, what you have an angle in all, and you have two sides. So we have an angle and two sides, and that refers to the right angle triangle. Now, in solving an equation, you're only allowed one unknown, unless you have simultaneous equations where you have two unknowns and you need two equations to solve that. But if you just have one equation, then we can only have one unknown and get solve for that missing thing. So it's either the angle is going to be missing, and if the angle is missing, you need to know the two sides. If a side is missing, you need to know the angle and one other side. That's the only way you can work with these trig ratios to solve for either the missing angle or the missing side. So here I have my first question where they want us to calculate the value of x. So x is the length of this side here. We have this 10 centimeters, the length of this side here. And of course, we don't know the length of the side. Now, with a right angle triangle, if you were to find a missing side and you had two sides on the right angle triangle, you can use Pythagoras' theorem to find the missing side. Now, why is we not using Pythagoras' theorem here? Because when you have one side and we have two sides missing, so therefore we cannot use Pythagoras' theorem to find this missing side. And that is why we are turning to the trig ratios. So first thing, you're going to label a triangle. The side opposite the right angle would be a hypotenuse. So this 10 centimeters would be a hypotenuse. The side opposite the angle that's given or the angle that you want to find would be your opposite side. So opposite the 60 degrees is x. And therefore x is our opposite side. And therefore this remaining side would be the adjacent side. So you're going to say so, ka, toi. And then you're going to check. What do we have? We have the hypotenuse. We don't have the adjacent. And we don't have the opposite side. But the thing is, we want to find the opposite side. Therefore, our trig ratio must have opposites. Now, if we look at our trig ratios, we are seeing so and toi has O in it, but ka doesn't have a O. Therefore, we are looking at sine and tan for now. So I'll just shade that sine and tan. But remember what I told you. You're only allowed one unknown. And since the opposite side is the unknown, which is what we want to find, therefore we need to know the other side and also the angle. Do we know the angle? Yes. We know the 60 degrees is the angle, and the other side would be hypotenuse. So when we look at the trig ratios, we're going to see which one has hypotenuse and also opposites. And that will be so. So this would be the right one to use, sine. So I'd write sine theta is equal to opposite over hypotenuse. And of course, theta is the 60 degrees. The opposite would be this x here. And the hypotenuse would be 10 centimeters. So we'll have sine of 60 degrees is equal to the opposite, which is x, over hypotenuse, which is 10. Now, in order to solve for x, I'm going to cross multiply. So I want to write this sine 60 over 1. So I write sine 60 degrees over 1 is equal to x over 10. Now, cross multiplying. When I multiply 1 by x, I would get x. So that's equal to, and when I multiply sine 60 by 10, I'll get 10 sine 60, which means 10 multiplied by sine 60 degrees. So I'm going to bring my calculator up. I'm going to make sure my calculator is in degrees. So I'm seeing a D up here. So that means degrees. All right. So there are other ways to measure angle, which is radians and gradians. So if your calculator is not in degrees and the mere fact that our angle is 60 degrees, and the calculator is, let's say, in radians or gradians, you're going to get the wrong answer. So make sure your calculator is in degrees. If you're doing higher level mathematics and you're measuring angles in radians, you make sure your calculator is in radians. Okay, so on this one, it will be R. Some calculators RAD. Degrees, this have a D. Other calculators is marked DEG. All right, and of course, gradients is GRAD in some calculators. And on this one, it will be a G. So, calculator in degrees first. Then you can type in 10 sine 60. So 10. Press the sign here. Hit open brackets. Okay, let's put in the 60. I don't need to close brackets for this one. And let's press equal. Let's convert that to a decimal. And we have 8.66025. Okay, right, this is 3 significant figures. So 8.66. So I'm going to write x is equal to 8.66 centimeters. So here for number 2, we want to calculate the value of theta. So theta is our missing angle. So this would be our unknown. Now remember what I told you. When you're using your trig ratios, you're only allowed one unknown. And this time the unknown is the angle. Therefore, you must know the lengths of the other two sides. Now we know the length of this side, which is 8.66, and this side here, which is 10 centimeters. So now let's label the triangle. So the side opposite the right angle would be our hypotenuse. So HYP for hypotenuse. The side opposite the angle that we want to find, or the angle that's given, is your opposite side. So theta is the angle that we want to find. So the side opposite to that would be the opposite side. And the next side would be the adjacent side. So again, we turn to our trig ratios and say, so, ka, toi. And remember, since theta is the missing angle, we need to know the lengths of the other two sides, which will be the opposite and the hypotenuse. So we are just looking for a trig ratio with both opposite and hypotenuse, which is so, SOH, sine is opposite over hypotenuse. So we're going to write sine theta is equal to opposite over hypotenuse. Theta is missing, so we're going to leave that as sine theta. The opposite side is this 8.66. The hypotenuse is this 10 centimeters. And now, yes, I could go on my calculator and put 8.66 divided by 10 to get whatever decimal this is. But I'm going to leave it like this. And what we're going to do to find theta is, we're going to write theta is equal to, and we're going to put sine inverse of this 8.66 over 10. All right, so this sign with this -1 means sine inverse. So let's go to the calculator. All right, and now watch this. If you just press sine on the calculator, sine comes up. You don't see -1 comes up with it to make it sine inverse. So what you have to do is press the shift button, shift, then sine, and now you see a sine with a -1 comes up, and that's sine inverse. All right, then you can put the 8.66 divided by 10. So this calculator, the brackets open one time. If the calculator doesn't open brackets, you open brackets. Put in the 8.66 divided by 10. Then you need to close the brackets and then press equal. And we get 59.997 to three significant figures. That's 1, 2, 3. After this 9 is a 9. So this 9 goes up by 1, which will cause this 9 to go up by 1. So we're going to get 60 degrees. So we're going to have theta is equal to 60 degrees. Now, not all calculators has the shift button. Some calculators have a button called second function. So let's bring up a calculator with the second function button. All right, so notice this calculator marks DG at the top. That means the calculator is in degrees. So all angles that we enter or trying to find will be given in degrees for this calculator. Now notice we have second F, right? That means second function. If I go to press sine on this calculator, see sine alone comes up. I'll clear that off. If I press second function, then sine, then the sine with the -1 comes up, which is the sine inverse. So this calculator needs to open brackets and then put in the 8.66 divided by 10 and then close brackets, press equal, and you see you get the same thing, 59.997 and so on, which is approximately 60 degrees. Now, if you look at these two triangles, they are the same. Hypotenuse is 10 centimeters, hypotenuse is 10 centimeters. The angle here, theta, is 60 degrees, and the side x we found as 8.66. So instead of putting x, I put the 8.66 and I put the theta missing. So that's naturally looking at these two, expect to get 60 degrees for theta. Now notice on the calculator, I got 59.997 and so on. I didn't get exactly 60 degrees. So why is that? Well, remember when we found the length of x here, we approximated this 8.66 correct at other decimal places. And because we use an approximation for this answer, which is the 8.66, and we use that back here, that's why we didn't get exactly 60 degrees. But of course, when we approximate, the answer that we got was approximately 60 degrees. Now, moving on to this question 3 here, we want to calculate the value of theta. So we're given this side here is 5 centimeters, this side is 10 centimeters, and we don't know the length of the side. But our unknown, which is what we want to find, is theta. So let's label this triangle. The side opposite the right angle would be a hypotenuse. So here's HYP. The side opposite the angle that you want to find, or the angle that's given, would be opposite side. So here will be the opposite side, and that's the side opposite theta. And the remaining side will be the adjacent side. So if theta is our unknown, when using our trig ratio, we need to know the other two sides. So you're going to ask yourself, which trig ratio has both hypotenuse and adjacent? So you're going to say, so, ka, toi, and see which one of these has both A and H. A for adjacent, H for hypotenuse, and that will be ka. All right, so you're going to write cosine theta is equal to adjacent over hypotenuse. So cosine theta is equal to the adjacent side, which is this 5 centimeters, over the hypotenuse, which is this 10 centimeters. And yes, I can break down this 5 over 10 and get a half. But as we know, we're going to be finding theta, so we're going to write theta is the cos inverse of this 5 over 10. So theta is equal to, and again, we go on our calculator, make sure it's on degrees. We're going to press the shift button first, then cosine. So you see, cos inverse come up. Let's do this over. If I just press cosine by itself, see, cos comes up by itself, no inverse. But if I press shift, then cos inverse comes up. Then I can type in the 5 over 10, which is 5 divided by 10. So brackets open for me already. So 5 divided by 10, I need to close the brackets, press equal, and I get 60. So that means theta is 60 degrees. Now, if I were to use a calculator with the second function button, all right, see the calculator is in degrees. I'll press second function first, then cos. So you see cos inverse comes up. I open the brackets and put 5 divided by 10, close brackets, press equal, and I get 60 degrees. All right, so moving on to question 4, we have this right angle triangle here that we want to calculate the value of x. And if you look at this triangle and this triangle, you can see the same thing because we found here theta to be 60 degrees, and I have 60 degrees exactly where this theta is. Then we have 5 centimeters down here and I have 5 centimeters here. So you're going to expect that x is going to be the same 10 centimeters. All right, so let's label the triangle with respect to this angle theta. So opposite my right angle would be my hypotenuse. So x is my hypotenuse. Opposite the 60 degrees, which is the angle that's given, besides the 90 degrees, would be my opposite side. And the remaining side would be my adjacent side. So this 5 centimeters is my adjacent side. Now remember, we only allowed one unknown, and that unknown is going to be x, my hypotenuse. So I'm going to say, so ka toi, and my trig ratio must have hypotenuse because I'm trying to find x, and x is my unknown. And when you're solving an equation, you're solving for the unknown. All right, so my trig ratio must have hypotenuse because that's my unknown that I want to find. I don't know the opposite, so I can't have two unknowns. So opposite and hypotenuse, which is sine, is out. All right? Then the other side is the adjacent, and I know the length of the adjacent. So now remember, if you're using the trig ratios and you have a missing side, so that's the unknown, you need to know the angle and one other side. And the one other side that we have is the adjacent. So our trig ratio would have the adjacent in it, and of course our unknown, which is the hypotenuse. So hypotenuse and adjacent, you say so ka toi. Which one has A and H? So, no. Ka, yes, A and H. So that's why we are using cosine. So you're going to write cosine theta is equal to adjacent over hypotenuse So cosine theta is the 60 degree right here, 60-degree angle. So cosine 60 degrees is equal to, and my adjacent is the 5 centimeters over the hypotenuse, which is x. So now what I'm going to do is put this cosine 60 over 1 so I can cross multiply. So when I multiply this cosine 60 by x, I'm going to get x cosine 60 degrees. And when I multiply this 1 by 5, I'm just going to get 5. So now if we have x multiplied by cosine 60 is equal to 5, and we want to find this x, I need to transfer this cosine 60 across the equal sign. Now remember, cos doesn't exist by itself. It must be cos of an angle. All right, so sine of an angle, tan of an angle, same thing. So the whole cosine 60 has to go together. It has to go across the equal sign, and it's been multiplied by x. So the opposite of multiplication is division. So when the cos 60 goes across the equal sign, the operation will change from multiplication to division. And what we're going to have is x is equal to 5 divided by cosine 60 degrees. So we're going to have x is equal to, and we go to the calculator. And we're simply going to type in, make sure, well, first of all, we're going to make sure the calculator is on degrees. Then we're going to type in 5 divided by, and let's type cosine, so cos, and put in 60, press equal, and we get 10. So x is equal to 10 centimeters. And of course, we was expecting that because these two triangles are the same. 60, here's 60. So if here's 10, here's also 10 because here's 5 and here's 5. All right, so moving on to question 5, we're going to calculate the value of theta again. This time we have 5 centimeters down here and 8.66 centimeters here. It's a right angle triangle, so we're going to use our trig ratios. So we know the side opposite the right angle would be our hypotenuse. Hypotenuse is also the longest side on the right angle triangle. The side opposite the angle that we want to find, or the angle that's given, is the opposite side. So this 8.66 is our opposite side. And the next side would be our adjacent side. So 5 centimeters is our adjacent side. So we're going to look at our trig ratios. So we're going to say so, ka, twa. All right, and just remember our angle is missing. So that means we need to know the lengths of the other two sides for the trig ratio. So the other two sides that we know the lengths of is the opposite and the adjacent. We don't know the length of the hypotenuse, so we can't use any trig ratio with hypotenuse in it. So see h here, and ka, those are out. All right, so that means it has to be tan. So let's see, opposite and adjacent, those are the length sides that we are given, and tan has what? Opposite and adjacent. So that's why we are using tan. So we're going to write tan theta is equal to the opposite over the adjacent. So theta is missing, so we're going to leave that as tan theta. And the opposite side is the 8.66. So we have 8.66 divided by the adjacent side, which is this 5 centimeters. So we're going to have theta is equal to the tan inverse of this 8.66 divided by 5. Now notice, whenever you're finding the missing angle using trig ratios, is always the inverse. So you're either using sine inverse, cos inverse, or tan inverse to find the missing angle. And of course, to find the length of the side, that's the one where we had to cross multiply. So we're going to pull our calculator up, make sure it's on degrees, seeing this d at the top here. Then we're going to press shift, then tan, so we get the tan inverse to come up with the brackets open. Then we're going to have 8.66 divided by 5. We're going to close the brackets and then press equal. And we have 59.999, which is approximately 60 degrees. So theta is equal to 60 degrees. And of course, if you was using a calculator with second function button, we'll press second function first, then tan. We have to open brackets here, so open brackets. Put the 8.66 divided by 5, then close the brackets, press equal, see same thing, 59.999. And notice the calculator is on degrees as well, DEG. So now moving on to question 6, we have x as the missing side, and we have this 5 centimeters down here, and given our angle 60 degrees, of course, is a right angle triangle, and we want to calculate the value of x. So let's label our right angle triangle with respect to this angle 60 degrees. So as by now, you know the side opposite the right angle is your hypotenuse. So this is your hypotenuse here. Opposite the angle that's given is the opposite side, so x is our opposite side. And the next side is our adjacent side, so this 5 centimeters is our adjacent side. We're going to look at our trig ratios, so we're going to say SOHCAHTOA. And remember, within our trig ratio, there are 3 things, an angle and 2 sides. And here we have a missing side. Therefore, we need to know the angle and the other side. So the other side will be the 5 centimeters that we know because we don't know the hypotenuse and I don't want to find the hypotenuse. So I'm going to use the adjacent side, which is the 5 centimeters. I know the angle, which is 60 degrees. And my unknown that I want to find is the opposite side. So my trig ratio would have opposite because that's what I want to find. And the other side that's given is the adjacent. So I need a trig ratio with both O and A. So I say SOHCAHTOA, which has O and A. This, O and H, no. A and H, no. Tan, O and A, yes. So that's why we're using tan. So I'm going to write tan theta is equal to the opposite over the adjacent. And remember, our theta is 60 degrees, the opposite is x, and the adjacent is 5. So tan theta, that's tan 60 degrees, is equal to the opposite, which is x, over the adjacent, which is 5. I'm going to put this tan 60 degrees over 1, so I can cross multiply. So when I multiply 1 by x, I'm going to get x. 1x is the same as x. And when I multiply this tan 60 degrees by 5, I will get 5 times tan 60 degrees, and I write that as 5 tan 60 degrees. So x is equal to, all right, we pull our scientific calculator up, make sure it's in degrees. I just type in 5 tan 60 equal, let's convert that to decimal, and we have 8.660. So the 3 significant figures, that's 8.66. So x is equal to 8.66 centimeters. And that would bring us to the end of this video.